Welcome to session 11, where we look at the TCPIP Transport and Application layers. This is the last in the series, and we'll talk about that in a minute. At the end of this session, I expect you to be able to do a number of things, and these are shown in this slide. Key topics that we want to cover is the TCPIP Transport layer. So we'll look at the application layer. We'll look at a number of things, protocols there. The reading list is shown on the slide that is up. So, the TCP/IP transport layer. The transport layer has a number of basic services or functions. One is segmenting upper layer application data, establishing end-to-end operations, sending segments from one end host to another end host, ensuring data reliability, and providing flow control. What is flow control? Avoids the problem of a host at one side of the connection overflowing the buffers in the host at the other side. It ensures the integrity of the data. Now, flow control, if it's not done, can lead to congestion. So congestion can be caused by faster computers generating traffic volume greater than the network is able to transfer. Large numbers of computers send data to the same location at the same time. There may be more than one application using TCP/IP stack at the same time. Port numbers are used to keep them separate. So that diagram shows you at the transport layer, they need to have different port numbers to keep your applications separate. Session establishment. So you have a sender, you have a receiver. There's first a synchronization. You synchronize, then you negotiate the connection. Then there's a response synchronization, and then there's an acknowledgement. Then the connection, once the acknowledgement is done, a connection is established, and data transfer can begin. And this data transfer can be in both ways. In a three-way handshake, you send a synchronization. So the synchronization is received at B, and then you send an acknowledgement, and then that is also received, and after that, connection is established. You can see why they call it a three-way handshake. Windowing is a method of controlling the amount of information transferred end-to-end. Information can be measured in terms of the number of packets or the number of bytes. A window size is the size in octets or bytes that the device with a source port transport layer buffer is ready to accept. Large window sizes would, of course, increase communication efficiency. So at the sender end, then at the receiver end, so you can see you can send ones and twos and three, which means the window size here is 3 because the receiver can receive 3. So that gives you an example of how the window sizes work. Positive acknowledgement requires a recipient to communicate with the source, sending back an acknowledgement message when it receives data. It's just courteous. The sender keeps a record of each data packet that it sends and expects an acknowledgement. The source must receive an acknowledgement before sending more data. So when you send the data, you wait to see whether an acknowledgement is received. If you don't receive that acknowledgement, then you don't send anymore. The protocols that are used at layer 4 are the TCP protocol and then the UDP protocol. The TCP data segment is shown in the diagram, tells you the number of bytes that are required in total. You require ports, a source port, then the sequence number, which is 32 bits, the acknowledgement sequence, acknowledgement number, header length, checksum, options, and then the data, which can vary. So what do those various things stand for? The source port is the number of the calling port. The destination port is the number of the called port. And the sequence number is used to ensure that the correct sequence of the arriving data. Why is the sequence number important? Recall that data packets are sent across the network and they may all follow what? Different routes, which means that they may arrive at different times. The acknowledgement is the next expected TCP octet, and the header length, the number of 32 bit words in the header. Reserved is normally set to 0. The code bits, window, checksum, agent, pointer, option, and data are all part of the TCP segment, and they are explained in the slide. So what are the properties of TCP? What you should know is that it is connection-oriented, it is reliable, unlike UDP, it provides our IP, it provides outgoing messages it divides outgoing messages into segments, reassembles the message at the destination, resends anything that is not received, reassemble messages from incoming segments. With this, you then can see the difference between TCP and then IP. You can actually see what the differences are. The UDP segment format is shown in that diagram. It's got a number of things: the source port, the destination port, the length, the checksum, and data. They are all explained in the slide. The properties. Unlike TCP, this is connectionless. It's unreliable. It transmits messages or so-called user datagrams. Provides no software checking for message delivery. Does not reassemble incoming messages. Provides no acknowledgements. And then it provides no flow control. All right? So, given all of these things, you then say, if it's got all of these things, it's not reliable. So why use it? But there are reasons why you use it. And this is something that I would like you to look into. And because we still use it, why? Under what circumstances would you use UDP? The diagram here shows you the TCP and the UDP numbers, yeah? So FTP is 21, Telnet is 23, STMP is 25, and those are TCP numbers, and the rest are shown. If anything at all, these port numbers you must know. You need to know these port numbers. They are important because you use them that often. Now, the protocol graph for TCP/IP. So what you see here are the protocols on top, and each protocol, whether it's related to TCP or UDP, and then how that translates into IP and then connected to the internet or your LAN or your LANs or many LANs or WANs. Let's look at the application layer. The application layer has a certain number of things, things happen there. You can have file transfers there, you can have emails there happening there, you can have remote logins there, and you can have network management, and then name management, happening at the application layer. These responsibilities include identifying and establishing the availability of intended communication partners, synchronizing cooperation applications, establishing agreements on procedures for error recovery, and then controlling data integrity. Examples of application layer are the domain name system, DNS, FTP, HTTP, and so on. Now, the diagram here shows you how you might do an FTP in a Windows environment, So we know this FTP is reliable, connection-oriented service that uses TCP to transfer files between systems that support the FTP. I don't know how many of you have used this FTP before in file transfers, but if you haven't, you might be interested to try it. Then there's a HTTP, which is a hypertext transfer protocol that enables connection between a web server and a client. Most of you use this protocol and you know it well. The port number is well known, number 80. That's what the port it uses. The SMTP is an email service which communicate with each other using the simple mail transfer protocol to send and receive mail services. The diagram here shows you how the STMP may work, but recall that SMTP offers very little security. There's no authentication in it. So when sending an email message, the process that is followed is to send a letter to the post office, for example, where the user belongs. The user then picks up the email. So this is a similar concept here, you know. So sending an email to your clients, and then you obtain the clients, you collect the person's post box as they are using POP or IMAP. There's a mail server, you know, through which this is done. SNMP, this is the network management system. They execute applications that monitor and control managed service devices. The bulk of the processing and memory resources required for network management are provided by NMS. One or more NMSs must exist on any managed network. Managed devices include or must contain as an SNMP agent that resides on a managed network. Managed devices collect, store management information and make this information available to NMSs using the SNMP. Managed devices, sometimes called network elements, can be routers, access servers, switches, and bridges, hubs, computers, hosts, or printers. So the diagram there shows you how the managed this thing works. You can see in the diagram the managed devices like your routers, so you have an agent which has got a management database there. You know, there's an NMS here, there's a management entity, and there's another agent here, another agent there. You know, so this is a central point. You know, it uses a majority of memory for resources. The agents will report back to this with their MIBs. So basically, that's how the SNMPs work. That's the structure of it. All information flowing from their agents that help to manage the system. Telnet is another client software which provides the ability to log in to a remote internet host that is running a Telnet server application. And then you can execute commands from the command line. Again, I don't know how many of you might have used this, but it's a very useful function that is available. And if you work in these areas, you'd somehow come across it. This brings us to the end of our discussions. I hope you've enjoyed the course, and thank you for listening.